Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to be serving you here today, as it is every day here in my virtual classroom. Step on inside as we jump into section 2.3 in the Big Ideas Math Integrated Math 1 textbook. We're going to be solving inequalities using multiplication or division. Now, we just solved using addition or subtraction in the previous section of 2.2 for inequalities, of course. And multiplication and division is just like what we did in solving equations using it. Multiply both sides by this, divide both sides by that kind of thing is involved. So just like the last section, this one looks a little shorter, which is going to be nice for us, and I'm looking forward to it. We're going to combine all the addition, subtraction, multiplication, and division in section 2.4 before we do the whole quiz review. Anyway, I'm just talking about all that because everything's leading up to that sort of. That 2.4 is really the one that's everything that's led up to it so far. Okay, but we got to multiply and divide. And I keep stressing that. There's one caveat in this one that's going to make this one a little bit more difficult than the addition and subtraction, and we have to keep it in mind. You might have done it before if you solved these. If not, I'm here to teach you it. So jump down to the description section below if you'd like to download this PDF, and if you'd like to find the timestamps of the problem sets, you can find them down below. Otherwise, we start with the lecture portion right now in 3, 2, and 1. We're going to solve by multiplying or dividing positive numbers and by multiplying or dividing negative numbers. And there's a difference between the two, not just in your boundary value, but also in what happens to your inequality. And we're going to do real life problems like word problems. All right, multiplication and division of properties, multiplication and division properties of inequality where C is greater than 0. C must be what they're multiplying or dividing by in this case. They're showing you if you multiply something that's a true statement, negative 6 is less than 8, 6 is greater than negative 8, things like that. If you multiply both sides by a positive number, or divide both sides by a positive number, you still get the same statement out where the less than is facing this way, the greater than is facing this way, that kind of thing. Unchanged. And they're showing that here. As long as it's a positive number that you're multiplying or dividing by. As long as that. Now, doesn't look like that they show the thing that they showed on the last one that I wanted to do, which was like, I can't probably do it justice, but it's like if you have some sort of A right here, let's say here's 0, here's A and here's B. If you multiply them, I guess this is Y. If you multiply them both by C, this becomes C times larger, so this is A times C, and then this becomes C times larger, which is B times C. It just becomes a much larger version, or a C times larger version of what it was before, right? Whether positive or negative, it stays on that same realm. Same with division. Anyway, these are also true for the less than or equal to, greater than or equal to. Now, our solving is no different from what we've seen in the past. X over 8 is greater than negative 5. That's division. So they're going to multiply both sides by 8 to solve for it. And X was greater, this was greater than before. It's still greater than after. X is greater than 8 times negative 5, which is negative 40. There's the graph on the number line, open circle, graph to the right. We can double check these by plugging in something like 0, and 0 should work. 0 over 8, or 0. Oh, here's the great thing about the division problems. 0 divided by any number is 0, and 0 times any number is 0. So if x is the only thing on the term, if x is the only term there, 0 is greater than negative 5 is true. So that's going to be really easy to test with 0. Don't make it harder than it should be. Now, negative 24 is greater than or equal to 3x. If we divide 3 from both sides, you get a 1x on that side and negative 8 on this side. Negative 8 is greater than or equal to x, and they do the smart thing in flipping the inequality to make it x is less than or equal to negative 8. Again, you can flip everything as long as you get the solution right. And to the left of negative 8 and closed circle is going to be there. Now, would 0 work? Plug in 0 right now. Boom. Is negative 24 greater than 0? No. Is 0 part of the solution set? No, because 0 would be over here, and it's not a part of it. Now, that was with positive numbers as we multiplied both sides by it or divided both sides by it. Now, what if you multiplied or divide both sides by a negative number? Take a look at the original set. Negative 6 is less than 8. What if we multiply by, say, negative 2? Negative 6 times negative 2 is positive 12. Negative 2 times 8 is negative 16. What was positive turned negative, what was negative turned positive, that's among them. A negative is less than a positive, but a positive is greater than a negative. Notice the flip that they did here. You flip the inequality once you multiply both sides by a negative number. Also true for division. You divide both sides by a negative number, the inequality flips. I technically would do the flip on this stage afterward when I get the result because I'm doing an action leading up to then, right? I wrote the statement first and then I do that. Now, They didn't do a drawing for this one either, but there's the property thing for it. The inequality flips when you multiply or divide both sides by a negative value. Now, just because you multiply or divide both sides by a negative value, it flips, doesn't mean if you had negative numbers before that they flip just because. In fact, I think they're saying that right here. Okay, they are saying that right here. You only do it here. It says a negative sign in an inequality does not necessarily mean you must reverse it. So they said example 1, right? Here, example 1 has a negative 5. I didn't multiply both sides by negative 5. I multiplied both sides by 8. Just because a negative 5 was there doesn't mean it flips over. The reason for the flip, and again, if they had that number line thing, it would look a little better. If I had, say, A and B right here, wow, that was a lot. If I had, say, A right here and B right here, if I multiply them by a negative number, what happens? A turns into negative, like negative 1. A turns into negative A. B turns into negative B. B was greater than A, but suddenly negative B is less than negative A. Greater than is to the right, less than is to the left. So it flips over when it multiplies by negative. It leapfrogs it, right? It goes on the other side in that kind of way, and that's what's going on here. That's the reason. And I'm not going to speak heavily on that reason other than a reminder to do it. So in this first example, y is divided by negative 3, so they'll multiply both sides by negative 3. That's where the flippage will come. Now keep in mind, I'll probably start it this way because I'm writing the statement. Then I multiply by negative 3, and then it flips. And now you have negative 6 greater than y, or y is less than negative 6. Now you can double check these, and here's where double checking 0 is probably your best thing to do anytime you have multiplication or division, because that's when you might have flippage. Now if I plug in 0 to here, that says 2 is less than 0. That's not a true statement. Well, 0 is not a part of the true statement, so that's right. If you didn't flip it, then you would have graphed this way. 0 would have been a part of your true statements, and that doesn't make any sense because that doesn't work to the original problem. Part B, example B, divide both sides by negative 7 in this scenario. That means this inequality flips as well. Now it's y is greater than or equal to 5. 0 is not greater than or equal to 5, so it shouldn't work. Let's plug 0 into here. Is 0 less than or equal to negative 35? No, and it shouldn't have worked, and so we expected that. Again, 0 is great on this. I'm not even saying negative 7 times 0 is 0. I'm just replacing it with 0 straight up. It's a really nice thing to work off. All right, let's do a word problem, and I think after that we probably do the problem set because it kind of reminds me of the last section. You earn $9.50 per hour at your summer job. Write and solve an inequality that represents the numbers of hours you need to work to buy a digital camera that costs $247. Do you need to make exactly $247? No, you could make $600, right? So you can make $247 or more. So, however much I make by my wage and hours worked must be greater than or equal to the cost of the camera, $247. 9.5 times n, if n is the number of hours worked, must be greater than or equal to 247 in my situation. If I divide both sides by 9.5, I can solve for that. Apparently, the integer value is 26. If I work 26 hours or more, I will make $247 or more. So that's it. I can work 100 hours and then it's $950. $950, yeah. Was there another part? Because this says if you have payroll deductions such as Social Security taxes, you need to work more than 26 hours. Okay. I don't think we have to include that part, but they're just telling you some life lessons here. Okay. And there's some good old double check stuff. Yeah, I'm all good on that. All right, guys, I'm going to dive straight into the vocabulary and core concept check, and then we have numbers 3 through 38 to do afterward. Actually, be numbers 3 through 39. Let me fix something on my end before I move forward. I believe it's a 39. Let me double check that, and I'll come back. Okay, yes, numbers 3 through 39 after this. So let's go ahead and start it off. Explain how solving 2x is less than negative 8 is different than solving negative 2x is less than 8. Well, here you divide by 2, and you get negative 4. And here you divide by negative 2, and you also get negative 4, but this time the inequality flips. Here, the inequality flips. Anytime you divide both sides by a negative. See, this divided from a negative. I couldn't care less what it divides from. It's what it divides by that changes the nature of the problem. Open-ended. Write an inequality that is solved using the division property of inequality where the inequality symbol needs to be reversed. Well, anytime you divide by a negative. So let's start with a negative here. It's solved using the division property. So we start with multiplication. Something like this. This can be, say, greater than or equal to 30. And now we solve this by dividing both sides by negative 3. So in these two questions here, they're really stressing the idea of by the way, this flips now. Negative 10, like that. They're really stressing the idea of dividing by negatives is something you got to be careful of. So they're really reminding you now before we get started. And guys, we're going to go ahead and get started. So numbers 3 through 39 will be had. I'll go as fast as this thing allows me to, okay? This says solve the inequality, graph the solution. We're going straight into this. They're not asking us for actions on tell me what you need to do. We are going to do it. So number 3, 4x is less than 8. We'll divide both sides by 4, and we'll get x is less than 2. As we do this here, notice that 0 will be a part of your solution set. If I plug in 0 into here, remember 0 times 4 is 0, right? Is 0 less than 8? Yes. 0 is a part of the solution. That makes sense. Number 4. 3y is less than or equal to negative 9. Divide both sides by 3. You get y is less than or equal to negative 3. Now, negative 3 is to 0's left. We're going to graph to 0's left as well, or to negative 3's left, I should say. So, and including the negative 3. So we won't hit 0. If you plug 0 into here, well, that's a y, not an x. If you plug 0 into here, you get 0 is less than or equal to negative 9. That's not a true statement. Therefore, 0 should not be a part of your solution set, and it's not. So we're all good. Number 5, negative 20 is less than or equal to 10n. Now, if you were part of my lecture portion, then you know two things of this. Number 1, we're dividing by a positive, not by a negative. Just because that was negative doesn't mean it's dividing by it. And number 2, so we don't flip the inequality. And number 2, I want to flip everything around, including the inequality. Now, flip everything around to get my variable on this side so that when I graph, it's measuring up against the boundary value and not the variable. Greater than or equal to negative 2 is this way for n, which includes 0. Negative 20 is indeed less than or equal to 0. Number 6, we have our last product one of this set. 35 is less than 7t. 7t, don't want to say 17. If I divide both sides by 7 in this case, this will be 5 is less than t. Swap everything around, t is greater than 5 is the way, that's the way we do business up in here. And we look in this way over here for t. All right. All right, now we have some values that are divided, and that means we're going to multiply to solve them. Doesn't look like anything here has negatives at the moment that we're dealing with, which is quite okay. X over 2 is greater than negative 2. I'm going to multiply both sides by 2, not negative 2. Therefore, multiplying by positive means no flip in inequality. X is greater than negative 4. Any numbers that are greater than negative 4 will maintain this status. That was a good straight line there. Sorry if it feels like I'm going too fast on these suddenly. It's just like, hey, I have no more really to say on this, right? Once you hit them, you hit them. Number 8. And I'd leave it above in case you want to see it there. A over 4 is less than 10.2. Whip out your calculators, folks. We got to do 10.2 times 4, just like that. And we're going to get A is less than, oh gosh, 40.8. I was going to say, I might need it in a second. A is less than 40.8. So here's 0. Here's 40.8 way over there. And A gets to be less than, which includes 0. I didn't check one of these yet. Is 0 less than 10.2? Yes. Is 0 part of your solution set? Yes. Did we get it right? Yes. Number 9. I guess this is more multiplication than it is division, given how I'm going to work it out. I'd rather not say divide both sides by 4/5. I'd rather not even say divide both sides by 0.8, which that's what 4/5 is. I'd like to say let's multiply both sides by 5/4. 5/4 here and 5/4 here. Still a positive. Still a positive. And 4 over 4, 5 over 5 are both 1. You have W on this side. And on this side, 20 divided by 4 is 5. 5 times 5 is 25. So W is less than or equal to 25 when you swap it around. Here we got our 25 and 0 being less than it, meaning it should work out. 20 is greater than or equal to 0 does work out. A and W. Like the root beer. Number 10. Negative 16, it's same like number 9. But negative 16 is less than or equal to 8/3 t. I will multiply both sides by 3/8, positive 3/8. And now here, I get t. Negative 16 divided by 8 is negative 2. Negative 2 times 3 is negative 6. So t is greater than or equal to negative 6. And there we have our t values, which includes 0. Negative 16 is less than or equal to 0. Okay, numbers 11 through 18 solve the inequality, graph the solution. Now, what I'm not enjoying about this, listen, all of these will have negatives. What I'm not enjoying about that is you are kind of now forewarned, whether it's me or the book telling you, we're going to flip the inequality. I wish there was a mix and match of these ones. Now, when you hit later sections, it's going to be that. Maybe even later in this section. But it's one of those things where I was like, well, you know what you're going to do. It's a little too automatic now. Divide by the negative, this turns into a greater than suddenly. This is negative 2. And this will work out this way. So here's negative 2 and 0. We're greater than it, which means 0 should work. See if we didn't flip the inequality. See if this works. Is 0 less than 12? Yes. And 0 should be a part of your solution set. If you graph to the left, 0 wouldn't be a part of the solution set, and that wouldn't make sense with the original inequality. When you multiply or divide both sides by a negative number, the inequality flips. And that's where I'm stating that I don't need to remind you in this set. We're just going to do it. So it's just that automatic. We divide both sides by negative 9 here. Y is less than negative 1. So we go to the left of negative 1, where 0 is not included. 0 is not included as 0 is not greater than 9. Remember, test with the original inequality, even if you start crossing things out like I am as we're working this. Number 13, negative 10 is greater than or equal to negative 2z. Hey, it's a negative. Negative 2, whoops, not z. I was going to say something else, and I do want to show it here in just a moment, just to slow things down a little bit. Z is here, inequality does flip, and this becomes 5. Now I'm going to flip everything, and this is kind of what I want to show you in a different light. Let's say I did the problem this way as well, and I will graph it in a second. Let's say we said negative 10 is greater than or equal to negative 2z, and listen, I'm well aware that this is the multiplication division thing, but what if I added 2z to both sides? Remember when we talk about making things positive versus negative? And I added 10 to both sides like this. Suddenly, this, hold on, I'm trying to keep this color-coded. Suddenly, 2z becomes positive, 10 becomes positive, and the inequality stays the same because all I did was just added things. Now I divide both sides by 2, and z is greater than or equal to 5. So this actually really helped me turning things positive, and it brought things to the left side of the inequality, and it still shows that it still works as an answer. So no matter what you do, you should still be able to get that, and that's a good indicator of how that thing works and when you might want to consider doing that for a problem, especially in the next section when you're probably going to have a lot of variables, right? Just a multitude of things to do. Put your variables on the left side of the equation, or better yet, make them positive. There are a lot of arguments as to why we might want to make them positive. This is among them. Same thing for this problem here. Negative 15 is less than or equal to negative 3c. What if I added 3c over? And I know this goes against what the problem's asking you to do, flip the inequality, but this is a reminder that the inequality would have flipped. So now this is 3c is less than or equal to positive 15. That is flipping the inequality, right? I just didn't divide yet. Sort of did. I flipped the inequality, the whole statement. C is less than or equal to 5. Same thing if you divided both sides by negative 3, it would say that. Okay, so this thing on this side, we include the 5. Remember, closed circle. I'm not stating this enough. I'm not stating enough. So 0 would work out for that. Negative 15 is less than or equal to 0. 4 more. These ones are division. These ones are probably less so ones that you'd be enthused to move terms over with. Once you see something as a fraction, it looks a little less welcoming, inviting. Now we're going to multiply both sides by negative 3, just like that right there. And multiplying by a negative means a flip of inequality. N is less than or equal to negative 3. So here's negative 3. We're going to go on this side. If I plugged in 0, it says 0 is greater than or equal to 1. That doesn't work, so 0 shouldn't work. Number 16. We're going to multiply both sides by negative 5, y'all. W over negative 5 is less than or equal to 16. Multiply both sides by that negative 5. I'll keep it in black this time. Negative 5 over negative 5 is 1. Inequality flips over to greater than or equal to. No change on there. And 16 times 5 is 80. So negative 6, or 16 times negative 5 is negative 80. Whoo, that's all the way over here. But we do include 0 because that's greater than or equal to negative 80. And it would work for this. 0 is less than or equal to 16. Number 17. We have a negative 1/4, which again, it'll mean an inequality flip, but that also means divided by 4. So when we multiply by the reciprocal, that is negative 4 over 1, we could also just call that, negative 4 times negative 4 times negative 4. It still kind of gets rid of all that. It's just a positive m over here. That flips. This is a positive 32 over here. Flip everything. That's my preferred method of graphing, seeing it in this way. And among other things, you get a hand cramp, man. I'm writing too much. And then number 18, we'll go typical reciprocal fashion this time. Number 18, we have negative 6 is greater than negative 2/3 y. Each time I do these, I'm telling myself to give myself space, and I never do. Multiply by negative 3/2, the reciprocal. See, I don't really give myself much space there. Boom, boom, all gone. Flip, don't forget that. Y, and negative 6 over 2 is negative 3. Negative 3 times negative 3 is positive 9. So y is greater than positive 9. 0 not included, as it shan't. There are my y's. Okay. That was a good heaping of problems. Let's keep going. Numbers 19 and 20, modeling with mathematics. You have $12 to buy 5 goldfish for your new fish tank. Write and solve an inequality that represents the prices you can pay per fish. So if you have $12 total, you can buy 5 goldfish. 5 goldfish times the price per goldfish, let's call it G, needs to be within or at $12. So less than or equal to $12. That would be the inequality. Write and solve the inequality. If I divide both sides by 5 here, I'm going to get, what is that? 2.4, so $2.40 per fish. No graph, but solve is right there. Needs to be less than or equal to that. It can be $2 per fish, whatever. Number 20. A weather forecaster predicts the temperature in Antarctica will decrease 8 degrees Fahrenheit each hour for the next 6 hours. Write and solve an inequality to determine how many hours it'll take for the temperature to drop at least 36 degrees Fahrenheit. So it's not saying that it was 0 degrees or whatever, but just says from wherever we're at, doesn't matter. And we don't need to put an X or anything. Just wherever we're at, we're dropping 8 degrees per hour times this number of hours for it to drop at least 36 degrees Fahrenheit, which means this or more. But the interesting thing about this is because these are negatives, that this or more really means this or less, because a larger negative is a smaller number. We want larger negatives, so less than or equal to negative 36. A little tricky there. But I think this will make sense when we do the solving for this. When we divide by negative 8, remember, this inequality will flip. I was sitting here thinking we wouldn't have word problems where we had to divide by negatives. Boy, was I wrong. And 36 divided by 8, I think, is 4.5. So H has to be more than 4.5 hours for it to drop more than 36 degrees with that in mind. And that's the flippage. Now, you could have gone without putting negatives to begin with. I just thought of negatives when it came to dropping, decreasing. So I wanted to kind of use that strategy. But that's why we flip, and that's why we're less than to begin with. Numbers 21 to 26 says, solve the inequality. Use a graphing calculator to verify your answer. I don't know. I don't know what to do to verify with a graphing calculator. I'm not going to do that. I'm just going to go ahead and solve these. This is 12 is less than y, or y is greater than 12. I don't even know what they mean by use one to, because I don't know what they mean. My graphing calculator, first of all, not everyone in IM1 is going to have access to a graphing calculator. Secondly, the graphing calculator I have access to that I use on my screen that you've seen before, I don't know how to graph single-digit things for a number line to show that it is what it is. Multi-variable? Yes. Not single variable. If I divide both sides by 17 in this case, I will get v is greater than or equal to 3. And again, they're not asking me to graph. They're saying verify with a graphing calculator, which doesn't necessarily mean graph. Number 23, 2 is less than or equal to negative 2/9 x. Oh, I should have left myself some room. At least these problems have a mix and match of, hey, we're doing negatives now. And if we're doing a negative, what does that mean for us? Well, first of all, 2 over 2 is 1, We're left with negative 9 here, but a flip in inequality and an x. So x is less than or equal to negative 9 is our setup there. X is less than or equal to negative 9. Number 24, also including a negative. So double stacked them. We have 4 is greater than n over negative 4. If I multiply both sides by negative 4 and leave myself with a little room, I'm going to have n here, a flip here, and negative 16 here. Turn everything around, n is greater than negative 16. Even though I don't graph it, that's your best way to go about stating it, personally. Number 25, solving for x in this case. I don't know how often we've done these ones where the fraction's on the other side, but we don't have a fraction to begin with. So with this case right here, you can say divided by 2, but to work with a fraction, you might want to say multiply by 1/2. Now this is a positive set, so we're not going to flip the inequality, but 3/4 times 1/2, 3 don't divide by 2, but 4 multiplies with 2 down here. This is 3/8. X is greater than 3/8. You multiply 3/4 by 1/2, this is what you get. And number 26, we get 1.1y, or we have 1.1y is less than 4.4. If you divide both sides by 1.1, maybe this is your use this to confirm. Maybe that's what they're talking about. Some of these numbers get a little weird. This is y is less than 4. 1.1 times 4 is 4. Nothing flipped divided by a positive. I like how fast this goes. Numbers 27 and 28 describe and correct the error in solving the inequality. You're going to bet somewhere they're not going to flip an inequality one using a negative. Here they multiply both sides by 3/2, the reciprocal of 2/3 to work that out. Negative 6 times 3 is negative 18, over 2 is negative 9. But they did flip the inequality. Oh, they shouldn't have done that. Now, I can imagine why they might have done it. Some might do it just as an automatic thing, just because they learned it. And they're like, oh, you got to flip it just because that's what I learned. You got to flip it. No, there's a reason behind it, and it's only when multiplying or dividing by negatives. They flipped their inequality when they shouldn't. They shouldn't have. I can imagine this is because the 6th was negative. The negative 6 is a negative number. But that was not what we multiplied both sides by. We multiplied from negative 6 with 3/2, but we didn't multiply both sides by a negative number. So the final answer, instead of x is greater than negative 9, is x is less than negative 9. If you work everything out the exact same, it would be the exact same. Just don't flip it. So they overdid that one. Now on this one, they didn't flip the inequality, which was the issue. When we divide by a negative of negative 4, then you should get that. Everything else seems to be mathematically right. That's an 8. But this time the inequality should flip. When dividing by a negative, both sides. Or multiplying. Inequality should flip. Now, I'm kind of glad that they did that for each of these things right here, because I can't think of other kinds of mistakes we should really refer to. So let's start from the top this time. The first one I kind of like. It seems strange, but, doing something when you shouldn't be is a part of that issue as well. So y is greater than or equal to, not less than or equal to. But yeah, this one, remember to flip it when dividing by a negative. Don't do it when you're not. I think that's a big thing. Don't do it when you're not. I didn't go to number 28, excuse me. Anyway, so there's the mistakes. I'm glad they're talking about it. And really, remember, they're really stressing it. Numbers 1 and 2, the vocabulary and core concept check, both stress this completely as well. All right, number 29, attending to precision. You have $700 to buy new carpet for your bedroom. Write and solve an inequality that represents the cost per square foot that you can pay for the new carpet. Specify the units of measure in each step. So we got a square bedroom of 14 by 14 feet. The area of that is going to be 14 squared, which is 196 square feet. If you multiply, let's see, what did they say? Represents the cost per square foot you can pay for the new carpet. If I have 196 square feet of carpet and I multiply this by X dollars per square foot of carpet, that cannot exceed $700. It must be less than or equal to that amount. So that's how I'm going to start by working this one out here. We divide both sides by 196, I guess, to figure out, did they say? Find it? Yeah, solve. Divide both sides by 196. Let me use the old calculator for that. It actually might be a kind of clean number because 700 is a multiple of 4. It might be... Oh, maybe it's not that clean. Well, it's 25 over 7. 3.5 something? Okay, let me try it. What is it? 700. Oh, my calculator's not responding. Hold on. Let me... Okay, you can't see what I'm doing. My calculator crashed. I have to bring it up again. I hate when it does that without telling me. Are you back? Okay, 700 divided by 196. I wish I had an actual calculator. Yeah, the 3.57-ish number. So X has to be less than or equal to $3.57 per square foot of carpet. That's the most I can spend on it per square foot in order to maintain that for my bedroom. Number 30. How do you see it? Let M be greater than 0. Match each inequality with its graph. Explain your reasoning. So with any of these problems here, understand that, I don't know, let me write this out. X over M is less than -1. When I multiply both sides by M, it says let M be greater than 0. Let M be a positive number. When I multiply both sides by M, X would be less than -M. So that graph would be C. C would be from part A. Part B is on the right side. X over M is greater than 1. Multiply both sides by M. It'll be X is greater than M. Boom, 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 boom. And greater than M is going to be A. A is C and B is A. That sounds weird. Part C, X over M is less than 1. If I multiply both sides by M here, it would be X is less than M. Notice I'm not flipping this inequality, by the way, because M's a positive number. That's what they stated. X is less than M is B. And the last one must be D. So let's see what's going on with D and make sure that that's right. Part D, negative, oh, here we go. Negative X over M is less than 1. Now, I want to multiply both sides by -M. That's what's going to get X by itself here. And because I'm multiplying by a negative, remember, M is positive, but it says -M. It's like 2 is positive, but when I say -2, that's a negative number. When I multiply here, this will be a -M here, but the inequality will flip. X is greater than -M, which seems to be D. So we're all good. So C, A, B, D are the answers to A, B, C, D. All right, number 31, making an argument. You run for 2 hours at a speed no faster than 6.3 miles per hour. Write and solve, I'm thinking that's slow for my pace. Write and solve an inequality that represents the possible number of miles you can run. You run for 2 hours. Okay, you know what, that's kind of a long time. No faster than 6.3 miles per hour. So when you go 6.3, hold on, let me think about that. When you go 6.3 miles per hour for 2 hours, 6.3 miles per hour times 2 hours, that's going to equal total distance. Your distance could be no more than however much you had that there. It can be no more than it. It can be less than or equal to it. Does that work? I think so. It's a different kind of multiplication because the variable's not on the same side as where you do the multiplication, but that'll be then 12.6 miles. You ran no more than 12.6 miles total. Part B, that's part A. Part B, sorry. A marathon is approximately 26.2 miles. Your friend says if you continue to run at this speed, you will not be able to complete a marathon in less than 4 hours. Is your friend correct? Explain. Well, if you did, I'm trying to think of what we'd want to do for the setup. I mean, I know what we can do, right? This is 2 miles. If you double it, that's 4 miles. That's 2 hours. If you double it, that's 4 hours. I get that. I'm trying to redo this though. I want to see how we compare to the 6.3 really. If I do X miles per hour, well, forget it. 4 miles, D D equals 6.3 times 4 miles, which is 25.2, I think. And 25.2 is not greater than or equal to 26 there. So you won't make it, sorry, 26 point what? 26.2. You'll be 1 mile short. You will be 1 mile short. I'm trying to think of the best way I want to do that problem. I kind of went more for proportionality of saying if I double that distance for that, or that time for that rate, then this is the distance I'll travel, and compared to 26.2. I could have said 26.2 equals 4x or whatever and solved for x and saw that that was more than 6.3 miles per hour. So there are a lot of options there. I don't know which one was best to state, but there's that. All right, number 32, thought-provoking. The inequality x over 4 is less than or equal to 5 has a solution of x equals p. So x over 4 is less than or equal to 5 has a solution x equals p. Write a second inequality that also has a solution of x equals p. We'll take a look. If I multiply both sides by 4 here, this is x is less than or equal to 20. What are values of p that we could be? P could be 20, 19, 18, etc. Can go down to 0, -1, -2. It doesn't have to be integers. It doesn't have to be integers, but I have to come up with my own inequality that would have any of these values as well. So let's say p was, I guess, because, what? I see. We don't make up what p can be. We have to make sure that p is valid for any of those, I feel like. So as long as we're less than or equal to 20 in our solution set, we're good. Has a solution of x equals p. Write a second inequality. Maybe you can make one up. Maybe you can make up 0. So let's just say x is less than 5. X is less than 5 if p equals 0. P equals 0. I don't really know what to state with that one. How about this? Maybe I don't say 5. Maybe I say 25. In that not all the solutions of x is less than 25 work, but every solution that contains x is less than or equal to 20 will be within this set. So I think that's how I'm going to say that, not the other way around. Number 33, problem solving. The U.S. Mint pays 2 cents to produce every penny. Oh, that sucks. How many pennies are produced when the U.S. Mint pays more than $6 million in production costs? When they pay $0.02 every penny times the number of p pennies, this ends up being more than $6 million. 6 million looks like this. So how many pennies? Divide by 0.02. Don't mess this up. 6, 1, 2, 3, 4, 5, 6 divided by 0.02. And I'm getting 30. I don't know if this is 30 million. Hold on. This is, first of all, it stays the same way. 1, 2, 3, 4, 5, 6, 7, 8. I believe 30 million. 300 million. 300 million pennies. We produce more than 300 million pennies in that situation. Number 34, reasoning. Our x is less than or equal to 2/3 and -3x is less than or equal to -2 equivalent. Explain your reasoning. I'm going to guess no. The reason is because the inequality didn't flip. Take a look at -3x is less than or equal to -2. We'll divide by -3. A negative over a negative is indeed a positive. This is 2/3. This is x, but this should flip. So not equivalent. Inequality flips. They would say explain your reasoning, and I say look at my work, right? That kind of thing. Look at the work. It's all there. All right. Number 35. Analyzing relationships. Consider the number lines shown. Aha. This is kind of like what I said in my lecture. I got A and B. Maybe they were different sizes, but write an inequality relating A and B. Well, A is greater than B. That's my part A. Part B, write an inequality relating -a and -b. Well, -a is less than -b. It's to the left of it. Part C, use the results from parts A and B to explain why the direction of the inequality symbol must be reversed in multiplying or dividing. Well, this is what I said in the lecture portion. That when you have A greater than B, you can multiply both sides by -1, and then suddenly this becomes negative A and negative B, but suddenly the inequality also must flip to less than. So explain if you multiply both sides by -1, the sizes of A and B are the same. Their absolute values are the same. The absolute values of A and B are the same. But now negative A is on the other side of negative B, making it less than. I know I'm not describing that best, but by multiplying by -1, it shows that that's where that's going to flip around. Now, I did that in my lecture portion. That was literally exactly what I did in my lecture portion. So hopefully you followed along with what I stated at the time, and that kind of pans out there. Or hopefully it pans out now. All right, number 36. Reasoning. Why might solving the inequality 4 over x is greater than or equal to 2 by multiplying each side by x lead to an error? Okay, hold on. 4 over x is greater than or equal to 2. Why might it lead to an error? Because we don't know whether x is positive or negative. Well, let me think about that. The 2 is there. Yeah, we don't know. We don't know whether x is positive or negative. As a value to begin with. You might say, we'll solve for it by doing this thing. It doesn't quite work that way. If it was negative, you would be dividing by the negative, and then it just doesn't really work like that, right? So then it flips the inequality. I think that's just the big thing. You may need to reverse the inequality when multiplying by the negative. Now you might say, well, Mr. Robinson, how's that any different than if it said 2x is less than or equal to 4 and you divide by 2 and you solve for x? We don't know if x is positive or negative. Well, you do when you solve in that case. But the thing here is that you never multiplied or divided by x. Here we got to multiply by x to make this so. So there's a difference there, and that's what makes it a little tricky. All right, number 37, mathematical connections. The radius of a circle is represented by the formula r equals c over 2 pi. Now, we did that in section 1.5 on literal equations, rewriting formulas. Write and solve an inequality that represents the possible circumferences c of the circle. This is r is greater than 5. We have a radius that's greater than 5. The possible circumference is c of the circle. So 5, if r is greater than 5, then 5 is greater than your circumference. Let's see. If r is greater than 5, then circumference is greater than whatever 5 times 2 pi would be. So circumference must be greater than, if you do times 2 pi, right? 2 pi times 5. So circumference is greater than 10 pi units there. Okay, number 38, critical thinking. A water skiing instructor recommends that a boat pulling a beginning skier, has a speed less than 18 miles per hour. Write and solve an inequality that represents the possible distances d in miles that a beginner can travel in 45 minutes of practice time. Okay, well, first of all, it's distance equals rate times time, but this time your time is going to be 3/4 of an hour. 45 minutes out of 60 minutes, which is 3/4, or you can say 0.75. Keep that in mind for time. A speed less than 18 miles per hour, your R needs to be less than 18. And this is the number of hours that you're going to be doing. 45 minutes out of 60 minutes is 45.75 hours. So your distance needs to be less than 18 times 0.75. less than 18 miles per hour, right? And solve an inequality that represents the possible distances. Yeah, I'm just setting up right here. Distance is rate times time like that. So 18 times 0.75 is it 13.5? Times 0.75 is 13.5 miles. So 13.5 miles. Last question, number 39, also critical thinking, says a local zoo employs 36 people to take care of the animals each day. At most, no more than, 24 of the employees work full-time. Okay? Write and solve an inequality that represents the fraction of employees who work part-time. Graph the solution. Is that addition? Is that multiplication and division, or is that addition and subtraction? A local zoo employs 36 people to take care of the animals each day. At most, 24 of the employees work full-time. So at least 12 of them work part-time. What do they say? Represents the fraction of employees who work part-time. Okay, so this is out of 36, so at least 12 of them work part-time. I was going to say P for part-time, but suddenly I don't know if that works that way. I'll just say X. X is at least 12 members part-time. Now, when you take the fraction out of how many there are, we divide that by 36. So that's at least 1/3 of them. At least 1/3 of them work part-time. Not 1/3 of a person, but 1/3 of the 36 people. So X is greater than or equal to 1/3 in that situation. So for me, as far as a graph goes, that's going to look like this. Now, it could go all the way up to one full, right, to one whole there. So I don't know. We're going to deal with compound inequalities a few sections from now, but this should stop at 1 technically, because you can't have more than 100% of people working part-time or anything like that. But guys, that ought to do it for this one. This is Mr. Robinson. Thanks so much for watching. Once again, it was another short lecture. I don't know if I'm going too fast for its own good. I very well may be. Apologize if so. But I think section 2.4 is more of solving using addition, subtraction, multiplication, division, combining like terms, distribution, all that kind of stuff. We'll have to flip inequalities. We'll have to graph them, probably even write out some word problems. We'll see. And then the quiz review off of that. So I think it's just building up into that so we can get a feel of each kind of property as it is. I hope that's okay. So thank you so much. Take care. I'll see you in that next one.